How many people are back? Yep. Can you switch on your camera? People who are back. Yeah, I have, I think 7 people only. So yeah, we'll have to wait for a few minutes. I hope people come back soon. Yeah, till that time, we'll do the YOLO V5. I've already introduced the YOLO object detection model. So folks who are already in can click on the first link I had shared, the YOLO V5 pre-trained model. Maybe one of you can share that the screen.
I have uploaded it and I have already extracted it, so I'll be sharing my screen.
Yeah, but we will be doing this one. I mean, as a second item, we'll do the
Okay.
first one, the pre-trained model, because we should go in sequence. First,
Okay.
we'll see YOLO V5 without any custom training, what it can do. Yeah.
Okay.
Yeah, not this one, the other one which I had shared in the chat.
Vidya, right, sir? Analytics
Can I
Vidya.
share it?
No. One more
No,
link is there.
This one is it? YOLO
Google
V5.
yeah, this
Colab.
one.
Yes.
Google
Yeah,
Colab.
this
Yes.
one. Yeah, this
Yes.
one.
Okay.
This
Okay.
one, right? Yeah.
Yeah,
Oh.
this one. So yeah, I hope, yeah. So please everybody come on camera who's not. And let's start the YOLO V5 one. I'm seeing around. So yeah, YOLO V5 is in already is an already pre-trained model, right? So you can, it is able to detect very common, most of the common items which we have, right? So we can use that. So this is the first example. This whatever you have in this collab notebook is created by Ultralytics, the company which created YOLO V5, right? So so this is their Google Collab. It's a YOLO V5 tutorial. So keep this in mind when you are doing. In future for practicing YOLO V5, the Ultralytics documentation is pretty good. So you can refer to the documentation. It is actually really good for understanding things. But there are two basic things you need to do here. You can do here. One is, as I said, pre-trained model. Without training the model again, you can take the existing YOLO V5 model and identify or detect objects in your image, right? In this case, whatever objects it has been pre-trained on, I think there are a large number of classes, it will automatically identify. So we'll do a demo of that. The second case we'll do, for that I had asked you to upload that data set. So that's something I think Kiran will come back to you in the second case. Second
Oh,
case
sure,
is
sir.
when we'll do the custom object detection. So you will learn how to detect train your YOLO V5 model to detect custom objects. So for example, maybe in your company a problem comes that, okay, you need to identify maybe whatever as some object, right? Some probably a machine, right? So then you can train your custom object model to kind of detect that. So let's do this. Let's start with the YOLO V5. And Shrikant, you were sharing, you can continue sharing. That's fine. Okay. So
Only does it require GPU this thing, sir? Like I don't know
yeah,
because my semantics is With GPU, it is still in 39th epoch, so I was still wondering. Like,
No
anyways,
worries, no
I'll give a
worries.
try. I will give a try.
No worries. Then you don't do it. We'll request someone else. You give the 70 segmentation. You give it a try. Till that time, you keep it running. Hopefully, it will free up your GPU for the next exercise. Yeah.
Yeah, yeah, that's the reason.
Okay.
Like,
So anybody else probably Sharon, can you share your machine in your Colab notebook for YOLO V5?
I'm not opened it, sir.
Okay, can open it. I think the link is shared. Anybody, any volunteer? I mean, if people are delayed, I don't want to. Like,
I'll start. Yeah.
okay, thank you. Yeah, I hope like by now everybody has come back. Okay, so go to the top, please. Yeah. So yeah, the first line here is the git clone, right? So this is you need to whenever you are running YOLO V5, if it is a local system, you need to download from the GitHub the code base of YOLO V5, which is shared by Ultralytics. It is free. You can easily download. So you can clone it. They call it the cloning, right? So clone your the GitHub repository, the YOLO V5 on your machine. That is what is doing. Then go to CD. Then the commands which says you go to the YOLO V5 folder, YOLO V5 folder. Okay. So okay. By the way, quick one. History of YOLO. YOLO started as YOLO itself. Then they improved it. It became YOLO V2, and then there was a YOLO V3 and 3 and 4. There is some controversy. Some people claim that theirs is the YOLO V4, right? But YOLO V5 is the latest one. There is no V6 till now, as far as I know. YOLO V5 is the latest one, which everybody uses for object detection. We will use that for now. So they are going. So okay, Python one property is there in GitHub, and in fact in any virtual environment. Not sure if you guys are aware. If you run a requirement.txt file, it will install everything which is there.
all the dependencies, yeah.
Dependencies, right? So that's just a Python knowledge. It's not nothing specific to YOLO V5. So they are doing that pip install minus QR, and again all these commands you can refer. Not very difficult. So pip install minus QR requirements.txt. You're installing all modules in Python required for YOLO V5. Then you are importing Torch module. Torch is again a just like Keras, it's a deep learning module based on TensorFlow. So from YOLO V5, import utils and okay, YOLO V5 and display. Okay. So just run this. First one you already run.
Yeah. Yeah.
Okay, good. So yeah, she's already run. So it is done. For rest of the people, please run it. Except folks who are, I think one or two of you are still running the older code. That's fine. Okay. So the second now here is the okay. So it's
Sorry.
very
My
simple. Go ahead.
this one. This one. Yeah. Second code.
Yeah, the second that yeah inference. If you see, they have showed you. No, above that there was something you were showing me just now.
It's a text, I think.
Okay, okay. So no, go to the text, please. We'll just refer to that. Yeah. So once you have put YOLO V5 folder on your machine or whatever, or you have cloned it in Colab, this is the syntax to detect objects in your image. Okay. So Python detect.py, you will write it. Then minus minus weights. Okay, that now source. What is the source? So it can take so many sources. It it can take your webcam. Is anybody here having? I think some of you might be having webcam. We'll try one of you probably. Webcam image.jpg is any image. We can take any image, whatever image you want. We can take it. Video.mp4 is any local video you have on your machine or any of whatever Google Drive you have. Path is again directly to a path of an image or a video. Then you can do a all the images in a folder using the globe command. Okay, that's fine. And okay, very interesting. We should do this one as well. You can do something on a YouTube video as well. It can run it on YouTube video and it will download it in your local folder after running. And then if you play that video which it generates, you will see your YouTube video have boxes around it, whichever object it identifies. Okay. And of course, it can do media files over HTTP stream, which is not very common, but in some cases it is happening. So you and your should be clear about what are the sources it can do, right? We'll try an image. We'll try probably a YouTube video. If there is a volunteer, I want to try a webcam also. Webcam also is very interesting. Okay. So let's do an image first. Can you open your folder structure, please? The on the left hand side, the folder sign which you have. Yeah. Okay. So if you see the open yellow V5, so expand it. Yeah. So if you see data, click on data. Huh. So in data images, you can copy whatever image you want to a YOLO V5 to upload. Sorry, to detect. Go to images, please. Under data images. Okay, so there is already a bus and a Jidan. Okay.
Zidane, yeah.
Yeah, yeah. So can you run this code? It's you already run it, right?
This one I did, yeah.
Yeah, yeah. So okay. So she ran Jidan, right? So it generates output where it is displaying here. By the way, confident. Okay, just a minute. Let's understand the other parameters in the command. So Python detect.py is fine. Minus weights is you. Okay, so YOLO v5 has a few variations. There are two or three models in YOLO v5, right? Couple, I think three of them. And YOLO v5s.pt is the most common. So please use it by default unless you have like you are getting very bad results and you want to try maybe a higher. It's like its difference is in terms of the weight, the size of the model. It is trained on with very large number of parameters, the other options, right? So YOLO 5s PT is the typically the weight of the model. It is already pre-trained model you'll be taking. Image size by default is 640. You can do it 640. You can change it also. You can see, but 640 works for all. Conf 0.25 means whenever uh, this detects this YOLO v5 detects an image, it will give you the confidence level it has for the machine learning model, right? For the object detection model. In this case, the person is 88% confidence, the model. In this case, it is 67%. In the tie case, it is 68%. You all can see the numbers, right? Tie is in this guy is the right side person. Tie is 26, right? So anything above 25% confidence, above equal to and above 25% will be shown. Anything which it thinks it is lower than 25, it will not show. So what you can do is you want like very good results. You can say okay, change that confidence level while you are running the command to maybe 60 or 80. Then you will only get very confident things. So your error will be very low. Understood what I'm saying, right?
Where have we given that input though?
Yeah, it is in the, if you scroll up. So if you see that python.detect.py code minus weights. No,
Oh,
not there. Just under that. The code block. Yeah, where is your mouse? Where mouse is?
yeah.
It's UC 640.
640 years.
Yeah, yeah, that line only. So confidence is 0.25.
25.
So if you change it to, so again, every time you run, it will generate a new output image in the which folder, see the second line, display.image runs. So there is a runs folder, runs, and the data folder, this is data folder where you have the image which you want to run. Now every time you run it, it will say detect experiments jidane.jpg, right? Just run this once more and increase the confidence level to 0.35, 0.50 maybe. You will not get the tie in that case. 0.50. Now run it. And you need to change the exp to exp1 because exp1 is the okay. It will throw an error because exp1, exp2 it is okay. Oh, result saved to exp2. Okay. So exp2, can you go to exp2 folder? You see that line, it says result saved to runs detect experiment 2. So every time you run it, it will create a new folder, experiment 1, experiment 2. Okay. I hope it is clear.
Where is it? Okay, results is
Yeah.
Runs folder. Not here, not here. Go to close the data folder. Close data, please. Runs. Runs may detect. Open detect. Detect you already opened. Open
Okay.
detect further. Yeah. Open
Got
detect further. Experiment 2. Now you download this image. You can see what it looks like. No, not that one. Experiment 2 one.
2, right?
Download Jidan. It will not show the tie on the first, the standing person, because the conference level is 0.T6. Can you open that image, what you have downloaded? Yeah. Oh, you can open using.
Okay.
So you see
Second
the
one.
tie is
Yeah.
no longer there for the standing person, right? Hope it is clear.
Yeah.
So it's pretty easy. Now let's try one more image here.
So in
Can
this
you?
case, it has already identified this like the one with the bald as Zidane, right? So it's like
No.
is it identified it as a Zidane or how is it like?
No. It has no class called Zidane. It has only a person.
No, yeah.
Person. Hmm.
He's the Zidane.
But he's
So
Zidane, I know. But
yeah.
there's no class called Zidane in the YOLO V5. It will identify it as person.
Oh, okay. Not to that level. Okay.
No.
Mhm.
That level you can train your own model with all the players, right? It can do that.
Okay.
That is your custom. That is the second part of this tutorial we'll be covering. Okay.
Oh, okay.
We are
But
just providing the image and it is giving us the I mean the detection that this is a person and this is a tie, is it?
but person and tie is just two labels. Actually, it can give you, I think, more than 200 or I think close to 500 labels it has. All common stuff which you see, right? You remember one of the slides in the last class I had shown for image AI model for object detection, which I am not running because it's an old model. Just for knowledge, I had shown you that had around 150 articles as labels, right? Laptop, pencil, pen, everything, all common stuff in the life, right? All daily uses stuff. Though YOLO V5 also has. Can you Google for this, Taruka? What is the YOLO V5 label list? Can you just Google for YOLO V5 labels? Not format, label list. Yeah. No. So YOLO V5 labels. Just write YOLO V5 labels. If somebody already found it, you can share the link here on the chat. YOLO V5 class names. In the first option which was coming. YOLO V5. We'll remove labels. Class names.
Classes?
Class. Classes. Classes. Fine. How many are there?
Let's do-
Guna? Okay, let me check. I think YOLO V5 is trained on Coco dataset. Coco has a lot of classes. 5 list. How many classes of objects?
Are these are the ones?
So Coco dataset has 80 classes. Okay. Can you show me?
No, I was just checking in images whether there are anywhere listed.
So one thing, as I said, there are 80 classes in Coco dataset on which YOLO was also trained, but it has also been trained on some other dataset. So it will be close to 100 is what I know. 100 classes, 100 very typical, normal, everyday things it can already detect. You don't have to do anything. Okay.
So Coco as in animation movie, yeah? Coco movie. That is okay.
No. Coco is a dataset. Yeah, Google for Coco dataset on this thing on your one of the folders. Yeah, one of the browsers tabs. Coco dataset, not YOLO V5. Coco. First one. See, Coco dataset is very popular. Coco dataset, first one, yeah. Yeah, so, okay, what is Coco? Coco is a large scale object detection, segmentation, and captioning dataset. So, segmentation we just did before the lunch, right? So, Coco is also for segmentation. So, okay, 330K images. Imagine. Today, last week's assignment had 1,000 images. This has 330,000 images. 180 object categories. Okay. So Coco categories is so YOLO V5 will have all these 80 object. Let's see. So please type Coco V5 object categories. It will give you here only. It will be there. We can easily Google for it. Just Coco V5 categories. Oh, sorry, Coco dataset categories, not V5. Coco dataset. Coco dataset.
Categories.
Uh, yeah. You see? Yeah. Can you click the first one? Oh, 91 objects it's saying. Okay. It's having around 91. Yeah. Go up. There's a link to the original data set. Somebody found it already? Go up. Okay, let me share. I'll have to share. Code data set categories.
Shall I unshare my screen?
No, no worries. I'll just give you.
There were 80 before they've added some more.
Okay, I got a very good link. The RoboFlow blog. Please open this. Yeah. Did you get it?
Yeah, I'm opening.
Scroll down. It has the class distribution as well, which is very interesting. More. Scroll down towards I think middle of the. Coco is used for a lot of. So you see, this is semantic segmentation data. 80 classes. Go down. Yeah. So these are the classes. Person, car, chair, book, bottle, cup, dining table, traffic light, bowl, handbag, bird. So if you see, these are some of the. So it is able to identify tie and other things. Tie is also there. Must be there.
But shouldn't the input be? This is a little biased, right?
Yeah, that's what. So that's why it gives you the facility of training your own object detection model, custom. It is not. I mean, it is more of a experimentation. So they have done all everyday common objects which you see: handbag, bird, boat, truck, backpack, whatnot, right? So from in your YOLO V5, this is the objects you can detect. Can you just quickly Google for any image, any maybe some image you want to detect? We can do that.
Mm, let's say
Any with which?
any ideas, guys? A toy, a doll, let's say.
Okay. Please, folks who are not on camera, please come on camera.
I think Daruka, it will help if we have multiple
Yeah. Multiple items. If you
objects
have,
actually. Yeah, multiple
yeah,
objects.
maybe marketplace or something like that.
Um, but let's
Be
say
a fair or a
Mm.
okay, mall.
Yeah, maybe a mall.
small.
Crowded mall. I'll check. I take this first one itself.
Yeah. Let's take a crowded mall. That's a good example. Let's see how good the model is with these things.
I think
Okay,
so.
the download image in your local, make it a something short or something, some short name, maybe a C1 or C2 or whatever. Yeah, mall one. Okay, till that time, like quick assignment to others, please find a YouTube video which is very short, maybe animals or something which has animals, just maybe 10 seconds, 5 or 10 seconds. Please find some YouTube videos, 15 seconds most. Please share with us any link like that. YouTube video with animals. We'll run this on that. Okay, so have you saved that image locally?
Yeah, locally,
Oh,
yes.
okay, go to that code now. We'll change something.
Yeah.
Okay, so in this code, you upload first in there. Go to data images. Upload your image where you want to do that.
So,
Left hand side data.
now let's see it here, no?
Data. Images. See, experiment runs. You don't touch. Runs. It will generate itself. Here you upload this new image. Now Okay, go to the code now, please.
Do I need to run it from the beginning or the second
No, no,
page?
no, no, no. Only this part, but don't run it
Yeah.
now. Just okay. So right now it says Python detect.py. It will run everything. Make the confidence back to 0.25, please, so that yeah we can see, because I think it's very crowded. We can want to capture as much as possible, right? And source data images is fine. So again, it will do for all three: bus image, mall image, Jidan image. But display image, do this. Make it experiment 3, because this is the third run you are doing, right? So it will create a folder called experiment 3 in the second line, line 2, exp3. Make it exp3
Made it. I think
and
it's like that.
make it
Done.
mal.jpg. Mal.jpg. MALL. So understood what we are doing?
Yes.
We are displaying what it will generate as an output, right? Let's do that. Hope everybody is clear what we are doing. It's not that it's very easy actually. You're a very
Oh,
powerful model. You can just okay. So can you see what all potted plant? Oh my god, it
yeah.
identified a potted plant as well. See, so many persons. Handbag it
Okay.
identified. Can you open
Yeah.
this in a large, maybe a larger image in your download and open it, or maybe open this image in a new tab?
Experience was inside a different one, right?
Yeah,
What
it
was
will
it?
be runs under runs. Close the
Right.
data one. Close the data.
Yeah, it should be here somewhere. Right.
Experiment is exp3, right?
Yeah.
exp, why is exp3 not okay? You will have to just
Okay. I think it was that.
yeah,
Yeah.
now it will. Yeah, it was not refreshed.
Mm.
Uh, no, don't do,
I
no, just
wanted.
open it. Just open it. It will
Okay.
have this already. Open it. Yeah. Now download mall.jpg. Now open that file. Okay. Anybody found a YouTube video, short YouTube video we can upload for object detection? Okay. So you see very clearly, handbag also it correctly identified. Score was 0.34. Persons, so many persons are identified. Potted plant is really nice. On rest of all are persons, right? This is a good one. It says a decent performance. You did not have to train anything for identifying probably. Anyway, you will not use a object detection model for such a crowded scene. You would use something else, probably a semantic segmentation model. Okay, but yeah, everybody is clear about how to use this pre-trained model for images only. Any questions?
Yes.
In terms of use cases, does a lot of retail sector use this to identify, I mean, understand the customer
Hmm.
who walks into the store and all?
Yeah, they do it, and yeah, object detection is used. So, for example, one of the very popular use cases was people wearing mask or not, right? So, mask can be identified, detected using this. There is, so all of you can do. There is a Kaggle dataset, I think, for masks. Okay, you can try. Just 1 second. I have to take one call. Just give me 1 second, please. Yeah. Yeah, sorry, I'm back. I have to take an important call. Okay, so
I share my screen.
yeah, please. Yeah, so image demo is done, right? Quickly, let's do one YouTube video. Can somebody already shared a link?
Yes,
Yeah,
so I've shared.
Uh, okay. Okay, let's take
You want me
Sharon's
to
one. Yeah,
you want me to
you copy what Sharon has. How what is the length of that video, Sharon?
It's a shorts video, so it should be very small.
Okay, yeah, shorts video has to be small, correct? That's can you click that, Sharon? What sorry, Taruka on what Sharon has shared? Yeah. Yeah,
Who's ready to hatch some cool
It is not
pets?
this one, the other one.
Yeah,
yeah, yeah.
Ariel.
Oh no, okay, this is 1 minute 18 seconds. It's slightly long actually. Let's do the other one, the first one before that. Taruka
Oh,
on the chat.
okay, my bad.
Yeah. That one.
Am I opening the correct one? Yeah, right?
Yeah. This is the
Yeah.
correct one. Okay, let's do this now. Let's generate this in. Okay, create a new piece of code.
Correct, right?
Yeah. You can close this now. We will just generate the output here. So okay, YouTube video very easy to do, but let's see output will also download, right? And okay, after image, same way you can do MP4 videos. Whatever MP4 videos is, you can do that. Okay, so can you, can you just add a code block here after the inference thing? Yeah, add one code block before this, not after this, before this. Yeah. Okay, actually it added after, but yeah, if you can, yeah, after, yeah, add it.
Okay.
That's fine.
Let's keep it here, yeah.
Yeah. So here just copy Python detect dot. Yeah, this is fine. Do put it in single quotes. This URL, YouTube URL. And do Python detect.py at top. Not top. I mean, we can bring it in the same line. We can do the Python detect.py. Copy that. Minus source also you copy. The rest all things you don't have to type. It will take all default values. So no worries about that. Yeah.
Before this, right?
Yeah. Unless I'm. Yeah. Weights. I think weights you will have to give. Let's see if it throws error. Then we'll have to give weights. But yeah, most likely not. Okay. So can you run this? I think it will give error. But let's see. Because I think weights we need to specify. Let's find out. Yeah.
Invalid. Why?
Sorry.
Oh, I think there's two. No.
No. You will have to give minus weights. Oh, you have to give this thing exclamation mark at the beginning. It's a command on the command line, right? So please do exclamation. Now see, is everyone else following? They're doing that.
Yeah, Ravi.
Okay, let's see if it takes.
I think it
Okay.
is.
Yeah. Okay, so it is already updating some modules. Okay, Okay, what is the error? Can you go down? Okay. Need 11 character URL. Okay. Shorts, I think it is not taking. It needs proper video URL. Okay, let me give you one.
Okay.
Yeah, I think
30
short.
seconds. 30 seconds video is fine, sir.
Yeah, fine. See, why I'm saying is because what it does in case of videos is it will break it up into images, frames. Now for a 1 minute video, it will keep running for maybe 10,000 images or whatever.
So I
5,000.
have just pinged a 30 seconds video, sir.
Yeah, you change that URL, what he has just typed. I think Kiran has given you just now.
Yeah.
Yeah.
It has so many animals in it.
Yeah, it is interesting. Oh, wow.
What did I do?
Okay. Just
Oh,
click it and then copy it from the YouTube probably. Do a Control Z here.
Yeah.
Control Z.
I'll open it.
No, you will have to.
Because I think
No,
I
just
copied.
click. I think there's a link which is clickable. You click on that.
Yeah.
Now you copy from the top.
Hey, Phil. These numbers from the LinkedIn ads we just ran.
Yeah. You can close that now. It is actually. Now you go to your code. And paste it. Paste it. Yeah. Now please run it.
talking about?
What is disabled? Okay. It is running. So you see, it is creating these images out of that, and it is doing that. It'll quickly, I think, finish. Anybody else trying the same?
Yes, sir.
Yeah,
Yes.
I'm trying.
Okay.
Yes, Ravi.
But under the EXP7, you get just one watch something.
No, it will
MP4.
can't turn it. It will turn into a MP4 video.
Oh,
You
okay.
can download and see it. Okay.
Okay. Okay.
Or you can run a Python command to render it. It's easier to download and see it faster actually.
Okay.
For you, it has already been generated.
Still the frames are being generated, but still I can see this MP watch video MP4.
Yeah, watch video will be generated. Yeah, let's just give it a few seconds. See, for 30-second video, it is taking so many frames, right? I think every few milliseconds it is taking. Anybody who is able to generate the video? So that's it. We'll now move to after doing that, we'll move to, what is that called? The custom object training. For this, we'll go to Kiran. You already downloaded the code, right? The downloaded the images.
Okay, sir.
No, but Tarika, we wanted to see the output of the video. Has that video been created?
I've
If that's
done
been
that.
created,
Mine just got finished. Yeah.
okay. Just can you share it again, please? Yeah. Download that video in the EXP4 or 5 folder, wherever it is generated.
It's the same type of code I need to run, right? Wait.
No code, no more code needs to be run, but you can just download the video which is just generated after object detection.
EX5, oh, it's here.
Yeah. So no, go to XP5. Yeah, download this.
No, it's not. It's getting interrupted. I'm not sure why.
Interrupted. Okay,
Yeah.
maybe some net probably. Anybody who has joined now was not present in the first half.
Oh, my bad. I think I'm downloading it
No,
one
no.
after the other. Yeah.
Yeah.
Couldn't see it properly. Yeah.
I just rejoined, sir. Like my internet just went down, so connected
No
to my.
problem. No problem. No problem.
I just
Yeah.
rejoined.
Yeah.
So
Hope
I
you're.
got one.
Ah,
Like I did for a video for 6-second video.
okay. Can you show it? You can you can share screen.
Yeah. Okay. So I ran the video and it showed done, and then it came here.
Now you
So
can
just
download.
opened it.
Yeah, you can click and open it as well. Yeah. Yeah. So it's identifying traffic light.
Train.
Train it identified. Good one.
Yeah, that's all.
Okay. Cool.
And that light above the train, right, in the olden days train. So
Okay. Got
it
it.
has
Okay.
detected it as
Interesting.
traffic light.
Yeah, this
Interesting.
animal video also, which
Ah.
Kiran had given, it's detected. I mean, it's quite
Can you
good.
show? Can you show it?
Yeah, I can.
Okay. So after seeing this, we'll move to the custom detection. A lot of stuff to cover.
Is my screen visible?
Yes, yes. Okay, it is identifying something as a cow. I saw that. Bird. Okay, that's not correct. Person. Zebra
Cow.
was correct. Zebra
Cow.
was correct. Cow. Yeah, cow is not correct. But
Well,
the
it's the same
confidence is
breed. I mean,
yeah.
not
So
This is
same
elephant is
family.
correct, yeah.
but if you give confidence level high, the accuracy will be there. See, it is not zebra, even though it is
It
0.83. Bird is not
was a
there.
lizard, it was classifying as teddy bear.
Yes, yes. Okay, cow and all. Okay, so yeah, it is. Yeah, so it is having trouble. But yeah, I mean, you get the idea. It's very good for
Yeah.
normal. So in fact, in standard object detection, if you have like retail scenario, I think these pre-trained models will work very well. Okay. Retail and also everyday business scenario, unless you have like specific machinery and maybe so as we saw, like for a wildlife sanctuary, you'll have to do a custom detection. Let's learn custom detection, which is very, very important. So Kiran, over to you.
Sure, sir.
Shrikant, I think your earlier code is finished running. The what is that called? The before the lunch you were running that, right? The semantic segmentation. I think your code was running slow, or somebody else said that slightly slow it was.
Mine's still it is running little bit slow.
How many epochs?
Same with me, Ravi. I think the second epoch is still running. Out
Okay,
of
okay.
50.
No worries, no worries. So if you want to like join this one, this is very important actually. Custom UL of 5, you can stop that. No worries. I think you've understood it will be running. It will run for you. You can kill your process and run that later on. Yeah.
Okay.
Let's do this.
Thank you.
Let's do this. Custom object detection is also very important. With this, we will finish our machine vision thing. We'll move to then text generation and bird fine tuning. That all are like small things. This I think will take some time, at least half an hour for understanding. Okay, so can you also open that? Okay, that let me
Yes,
not
sir.
trouble you. No, don't. I'll I'll probably refer that and talk to you guys. So okay, so the idea is just 1 second. Yeah, so this example is for detecting and classifying different types of road traffic signs. Now, one interesting thing is there are like 60 plus traffic signs they are identifying. So you see the number of labels is quite good, 60 plus, right? So can you show some images, please? What you have used? Not the one you uploaded, but if it is locally, have you copied locally? Can you show some images from there? You are a Kapil Sharma show fan. You just saw, yeah.
I'm so sorry. I was speaking on mute, sir. Is this the one that you want me to extract, sir, locally?
Oh, it will take a lot of time, is it? No, I was just wanted to show the class some examples. If it is taking a lot of time, then. But yeah, just see if it is. You can see some images. Testarian. Okay, Testarian is the folder name. Okay. No, test will not have. Okay.
I think you can just directly
It has
click and it
image.
will do it.
Yeah, you can just click it. Actually, I think it will
Yeah,
show.
you can click it.
It will show some examples.
I have it.
Started.
So I have done it. It's
Okay.
open on my machine.
These are the images, sir.
Just open the first one, PNG. Okay. Okay, you see, it's actually pretty challenging. It has road signs on within the road, actual roads. So it's a good use case. Let's do this. This is a very good use case. Okay. So yeah, better than I think the first one. I actually planning aquarium, but this looks to be a better. So okay, you see on the left hand side the road sign. So it will identify road signs like this. So again, it is a good one for driving. Okay, let's do this. Let's go to the code, Kiran.
Sure, sir.
Okay, so
I connected Google Drive.
Yeah, can you slightly increase the font size so
Oh,
that?
sorry.
Yeah. No problem. Yeah. Oh, it is already 110. I can't believe it.
No, no,
It's
I just increased it to 110. So it was 80
okay,
before.
okay. No, no, I thought 110 looks so small. What happened? Okay, Google Collab. Okay, so this is all Drive and all. That's fine. Can you go down? Okay. By the way, this article has some interesting facts. While you kind of run the code, it's a YOLO V5 is 88% smaller than YOLO V4, but it is 180% faster, and it is more accurate. But YOLO V5 has less documentation. That is not an issue. People have written tons of blogs. There are a lot of, so YOLO V5 has a lot of YouTube videos for custom object detection. So apart from this article which I shared, if you Google on YouTube, if you search on YouTube, custom object detection YOLO V5, you will find at least 50 videos. So please have a look. There are different kind of data sets they have used. Okay, so the steps are preparation and pre-processing of data set, training the model, prediction and live setting. Okay. So I think the steps which you need to start for is YOLO V5 thing which you have done.
Here, sir, this one, clone.
Clone is done.
Okay, it is done. And I got a folder
Uh-huh.
by this name.
And after then
And
you
then
have to, you're done. This is also done for you. Requirements.
requirements. Yeah.
It's done, no?
Yeah, done, sir. I ran it.
Okay. So then let's go to the next one.
And then I unzipped it.
You've done it actually.
Done it.
Have you done it?
And
Yeah. And
yeah. And then if I
okay, what's
check,
the next command he's saying?
so I just wanted to show you this. It's taking time.
Is the code for that is shared, sir?
Yeah, I think you're taking, Kiran, you're taking it from the article, right?
Yes, sir. I'm taking from the article.
So that analytics Vidya link I shared before lunch, right? That has all the
Oh,
code, step by step explained.
Okay, sir.
Okay. Hope everyone has got that, or if not, please refer to the analytics Vidya link shared just before lunch in the chat.
Okay, I don't know. I keep getting this message, sir, that
No problem. I think we've used too much collab today
yeah,
for heavy
okay,
duty
I
stuff
think
like
some
segmentation.
sure, sir.
I have a query. Actually, I have killed all my sessions. Still, I am getting a pop-up saying that connect without GPU.
I think because of see the semantic segmentation and detection and other things are slightly heavy processing wise. So that's why it is probably saying that. But yeah,
But I've
he's
killed
like,
my sessions actually, active
okay,
session.
can you
I
restart or
had to
something?
upgrade it to Pro.
Oh, you upgrade to Pro.
For
Okay,
I mean
that's
monthly
best.
$9. Yeah,
Yeah.
$9 because
Uh,
it's faster. I thought I'll use it this month and discontinue.
Okay.
So, but what we can do is I created another ID because I have
Mhm.
two IDs now. This
Okay.
is the ID that I created yesterday. So if I get that error message right, I
Ah,
just switch to the other ID.
awesome.
And
That's
and I have and I have files uploaded to both the IDs at the same time.
brilliant. Okay. So yeah, you'll get extra marks for this for sure. So, just kidding. Okay, but yeah, good. So yeah, good workaround. But yeah, so what Taruka has done is also a good idea. Because the unless the data is really confidential, but yeah, Google Colab is the best hardware for running deep learning models. Easily available. You don't need to spend money on hardware GPU systems. Okay, so image data set we see everything is there. Train.py, tutorials.ipnb. Yeah, this is YOLO V5 actually. Yeah,
This is YOLO V5, sir. An image
correct.
data set. I have it over here.
Yeah, got it.
This is the image data set.
Uh, okay, so virtual environment we don't need to install because we are running on Colab anyway. So
Okay, sir. So I'll just delete this then.
test and train
So I
is
have
there.
test and train. Sir, but actually the name is test underscore Aryan and train underscore Aryan. I have just renamed it to test and train.
No worries, we can take care of in the future code as well. You can share this code what you are running with the class, entire class who are otherwise people can download it or like copy it from the link analytics vidya.
Sure, sir.
Okay, so
So this is done. I'm done running
let's
it.
move
So
to the
I'm not running.
now let's move to have they processed the label files, the text files for labels. Okay,
Sure,
can
sir.
you show one example training data set image you have shown? Can you show uh, the this thing, the label, the So when you create this, right, when you do object detection, the training data set will be in YOLO v5 format, not this one. If you go to the data set, you will have text files which show you the coordinate of the box around your thing. Not here, not here.
Where,
The
sir?
raw data, the raw data.
The actual raw data, is it this one?
The actual raw data. I not in that, yeah, in actual raw data, are there any labels separately?
Yes, yes.
Yeah. So the label, one of the labels you open, I want to show the class how the label looks.
Where,
Because
sir?
training,
Like,
train.rn, go to train. Test
okay.
there will be no labels because test you will have to generate. Text. See, very important, every image, same name, one.png, there is a one.txt. TXT is the coordinate of the label. Open that, please. Any of it.
This one, sir. These two.
Ah,
I'll just open these two files.
no,
This
open,
is
yeah, these two. Yeah, okay. These two files, okay.
Okay.
Okay, so open one. Yeah, so this is the image. Now there are road
Okay.
signs on the left, the 100 which is written, right? Now see what is the.
This is the.
Okay, so you remember there were 60 classes. The article said, right, at the top of the article there are 60 classes. So this is class number 57. So 100 sign, the speed limit is class number 57, and those are, if I remember correctly, in YOLO v5, that is X central and Y. I think X mean and okay. Let me not guess it. Let me give you the exact YOLO v5 format. YOLO v5 label format. Yeah. So each data set you see is each class X center. Each row is class, then X center of X axis, Y center, and width and height. Okay. So can you open? Kiran, can you open this? I'm pasting in chat. And this training data, again, as I said, there are free tools available. You can draw a box like this and it will convert to automatically to these numbers which you got, right? Okay, go down.
Which one, sir?
Yeah, slightly. Yeah, this one. So yeah, so your training label, each image has this. So when you draw the box, each row is class. The each row of that label is class, which is class number 57. Now center of X. And so what is center of X? So it is normalized. The coordinates are normalized. Okay, it is they divide each coordinate by the total width and each height coordinate by total length. So that is why you see every number between 0 and 1. Hope you got it. Right? Is it clear? So 57 is a kind of, so maybe assume 57 is person. So person box 57 on this image is X center is 0.084. So the center of that image box is at 0.084 coordinate. Y center is 0.59. Okay. If you see
Okay.
Jidan's, so okay. If you see Jidan's image on the left, his X center is 0.48 and his Y center is 0.63. Okay. And total width and height is 0.69 and height is 0.71. Okay. So that's the four things which they capture in while for training. Okay. Using that, they draw the box around Jidan. Hope it is clear. This is, see, Kiran, don't need to write it here. It is already present in documentation. You can understand. This link is telling you with an image. That's why I chose this link. Hope it is clear. X center is 0.48, Y center is 0.63, and the total height and total length. That is the four things. If you give it, the model is able to draw a box while training, right? So model is not human. It will not care for box. You will have to explain the box in terms of these numbers. So it will say, okay, on this image, label number 57 was found on these coordinates. So you train. So it will say, okay, this kind of pixel values is under this label, right? It will learn. So it will learn how to detect. Okay. Is this clear? The training data concept, training label concept for each image. Okay, let's go. Let's do this.
So this requirements, I'm not able to run it. Maybe I'm not in the right directory, is it?
But you
Uh,
ran it earlier. Okay, yeah,
yeah,
you're
but
not in the right directory. You need to go to
yeah,
YOLO V5.
I'll just check. Sir.
Yeah.
Okay. Okay. So it's run. And this I'll skip it, sir, because I have already unzipped
No,
it.
don't do
So
that. Otherwise, you will have double the work.
Sure, sir. Okay, so I'm on YOLO V5.
Let's now run other things. There are two files which are useful while doing object detection, custom object detection. It is called data.yaml. Okay. So you need to create this. So please focus on your screen what we are covering. Very simple, but two very important points. You need to create a file called data.yaml and paste the below code what he's pasted.
Okay.
So this file will contain your labels and the path of the training data set. Okay.
Okay. So how do we can we use?
You use this thing. You can
I'll go to the collab.
upload it. See, you create one data.yaml file on your desktop, copy everything and upload it.
Sure, sir.
Maybe do a word file. So data.yaml is nothing but you remember Python detect.py we were doing in last session for these images. So in that only you will write, okay, where data.yaml file is found. It will then not use pre-trained model. It will go ahead and use your specified labels for training it. Okay. That's
okay. YAML. Live. Switch the account. Day 4. 5. And I'll upload it here, sir.
you upload it there wherever it is asking you to. YAML file, it has given the path where you need to upload.
Yeah. So this is my data.yaml file.
Yeah, data.yaml file, and you will need one more YAML file. They will tell you. Okay.
Okay.
Yeah.
Go back and I'll check if it's there or not.
Please check.
Yeah, I have it, sir.
Okay, awesome. So please have a look. Data.yaml was created with, just show the data.yaml file again, open it in WordPad. What you have done, the power, I think Word++ you are using.
Yeah, I've just opened it on the Google Colab also.
No worries. So yeah. So see, two things are required. Your training dataset image path, validation image path, number of classes, NC, colon 77. 77 classes are there. And all the 77 names are there. 200 m, 550, 200 meter, ahead, left, ahead, right, blah, blah. That's it. Okay. Let's move to the next steps.
Okay. 77 different classes. So I'll run this one, sir.
Yeah. No, YOLO fee. Oh yeah, okay. It's only needing data.yaml. YOLO 5s YAML file it didn't want to create, right? Okay, fine. Then only one YAML file is required. I recently remembered I had done a couple of YAML files. Okay. Let's
this
run
file.
that.
Okay.
Yeah, let's run
I'll
that.
run this.
Yeah.
Gave an error. So train.py.
No, you have to give that exclamation mark, right?
Oh, sorry. But okay, sir.
Name after name, you can give any model. You can say YOLO V5 model for traffic science or something like that. Is anybody else able to train this? You see how simple it is, just that it requires some steps to be carried out. You are using a Tesla K80 GPU, right? The top it is saying.
This one, sir.
Can you? So you see, interesting line. It says overriding the pre-trained model YAML with where the number of classes were 80. So we just saw, right, 80 classes in the pre-trained COCO dataset model, right? YOLO V5. Now you are override it with NC equal to 77. Your number of classes is 77. Go down, it will give you some statistics on how the model is training.
Oh, sir, 299 epochs.
Mm-hmm. How many epochs happened? How many epochs total?
I think 300, sir.
So that's done. No, but 0 to 299, it is still not completed even one epoch.
Not completely one.
Anybody for whom it is running fast?
Just now it completed one, I believe.
Anybody else who is running this?
I'm running it, but it's not on GPU. It's on normal CPU.
For you, it is taking one, Kiran. It's took for one epoch. It's taken how much time?
I think the
7 seconds. No.
1 minute, sir. Close to 1 minute.
Then it will take like 5 hours.
Should I cancel?
No, don't cancel.
Okay.
Keep it running. Anybody for whom it is running slightly faster?
Kiran, can you please scroll up a bit? I'm getting an error. So this code only. Can you just scroll up? 1 second. The Python one. Yeah. The Python train. Yeah, I'm using the same thing.
Even I got an error, but I used this exclamation mark just before typing.
No, I used that exclamation as well.
Okay. See, actually, I have done the data set that we have, right? So
Yeah.
it is having this test underscore Aryan, train underscore Aryan, that name. And even the extracted folder, it has 114 for images underscore Aryan, not dataset. So I manually changed that in my dataset. So I changed underscore Aryan to underscore dataset. and whatever test underscore RN that we had, I changed it to test and train.
1 second. So where are we mentioning that whether it is test? Yeah, okay, got it.
In data dot YAML file, right?
YAML, yeah, we are mentioning
Yeah,
that, right?
yeah.
Let me just change this one.
Sure, sure. It is running 1 minute, sir. 1 minute. On epoch.
It'll take 300 minutes, so 5 hours. So yeah, we should have started this morning first thing, so it would have run by now.
Or else, can we reduce the epoch size anywhere, sir?
No, run it, no worries.
Okay.
This. So what are some of the next steps in that code? Can you just go and see?
But where are we providing this epochs?
Yeah, it was,
It's
I think, in
predefined
the
model.
in the YAML file, they have
YAML
predefined
file,
it. You can override it here by doing epochs. That's a good question. You can specify epochs here in the Python train.py. You can specify. Okay, let me give you that syntax. Just give me 1 second.
Yeah, I was also checking YAML. So how many epochs is it? 200, is it?
300.
300.
3. Okay, YAML. There is something mentioned 200.
Okay, so people have done 30 epochs as well. So you can give an epoch parameter, okay, and it will only run the epoch for that. I mean the code for that many epochs. Let's
So
see.
should we give minus epoch?
No, epoch colon. Like, just like he's given data, right? He's given data and data.yml, right?
Yeah.
So yeah, minus. Yeah, correct.
Minus.
Minus epoch and then the epoch. Yeah.
Okay.
See if it is working. Want to kill this and run it again?
Sure, sir. Sure, sir. I'll do that, sir.
Sir, how many epochs can we use?
We'll use 10, sir.
Is for time saving time is using 10, but ideally 100 I have used and it has given good results. But not the best result. 300 epoch is actually required. 300 is good. So the
I'll
good
run,
thing
sir,
is,
with 10.
yeah, please. Anybody facing any basic issues here? Okay, here is one article which has definitions. It's a very big article, but has a definition of all the parameters you can use while giving command. Very good. I found it to be very good. This blog.paper space. I just pasted. Yeah. Custom data. Use yeah. Search for control F. Search for epochs. This is the all the parameters. Yeah, the epoch's the first one. Yeah, this one. Scroll up slightly here. Yeah, training options. So it has given complete options here.
Okay, let's see if this. I'll close it, sir.
Yeah, please close it. Yeah, just for reference for people.
His parameter instead of epochs I gave as epoch, still it is working. I think both
hey, he's also given epoch.
Yeah.
I think epoch is the correct parameter.
Yeah, in the article they mentioned epochs. That's it.
Okay. So article I think I tried epoch when I was running the code late last year for my office project.
No, they have given epoch, sir. Correct.
Okay.
Come on.
You never know, the developer might have given provision for both. Okay, so hopefully, so with this, we'll see. We'll wait. Luckily, we'll get. I mean, hopefully, we'll get output for at least some people, right? With this, we have covered almost all the basic things in machine vision. All the fundamental things in machine vision using deep learning, image classification, image segmentation, semantic segmentation or image segmentation, and also object detection, both pre-trained and custom. So please continue practicing. You have now all the things which are latest in the field of machine vision we have done. We'll do one more thing, which is transformers in machine vision, which is I will show a couple of collab notebooks where OCR is being done using transformers. It is very, very powerful. Yeah, let this run. We'll discuss this. Let me jump to language models for the time being. Okay, I'll share screen.
Okay, sir.
Okay, please come on camera, folks. Yeah, so I'm sharing my screen. Can you see my screen?
Not yet. Yeah, we can see it now, sir.
Okay, so yeah, so what is GPT-2 and GPT-3? Has anybody of you heard about it already?
Yes.
Okay. Yeah, so it's very famous actually. A lot of news articles have covered it over the last two years, right? So GPT-2 came, I think, around 2018, and GPT-3 2018 2019, I think. GPT-3 came in 2020, right? And both these are transformer based models. Again, transformers is the latest in NLP, right? It's a very powerful model. It is able to, and as you saw in the quiz question, the two important things to keep in mind: why does a transformer work so nicely compared to an LSTM and RNN? Because of attention mechanism, right? Something called as self attention. It is able to find relationship between words of an input also. So these are based on the transformer architecture, but we cannot train this unless you have like access to super powerful hardware, right? So let's look at GPT-2 first, which came first, right? So it's a large transformer based language model with 1.5 billion parameters. Okay, so look at the scale of this thing, right? The model parameters are 1.5 billion. Such a model would have been trained on a huge data set. It is written here. trained on a data set of around 8 million web pages, right? GPT-2 is trained with a simple objective: predict the next word given all of the previous words within some text, right? So when you're training some model, right? So remember all the models we have run till now, all the problems we have solved, we have given a training data and we have asked it to predict something, right? Based on training data. You all agree?
Yes.
Okay. So in this case, the task is very simple. It is saying I will give you this 8 million pages, and I will just keep giving you some data, and I will ask you to predict the next word for this, right? So maybe I'll pick up the Wikipedia, all the Wikipedia articles, and I'll keep giving you 100 words of each Wikipedia article and predict the 101st word, right? When I keep training that, this is a huge model. It will learn, all the parameters will be learned. Now it will become very good at predicting the next word, right? That's the whole idea. After the model is trained in a few days, right? Such a powerful model will still take a few days to train, right? I think it is maybe a 1 or you can Google for it. How much time will it take to train GPT-3? It will be easily in days, if not probably more than that, right? So once that model training is complete, now what the model can do? Why is it called a language model? A language model is a kind of a model where it predicts what is the next word, right? So if I say hello to you, right? So and then what is the next word? If somebody is not familiar with English, right? They will go to all the English text they have. They have some historical English, all I mean, how people talk to each other. They will do statistical analysis. They will find out, okay, if hello was said 5 million times, what word came out of hello, right? So then they will say, okay, hello, after hello, how word, hello, how are you? How word came maybe 25% of the time. Then another word came maybe, instead of how, another word came maybe 10% of the time. Another word came just 2% of the time, right? So according to statistics, hello, after hello, how are you, right? So hello, how is the word which comes most frequently. So that's what statistical machine language translation tells you, right? So this is much stronger than even statistical machine, not translation, statistical language model. It is actually learning based on connections between different words, not just immediate previous word, which a statistically, if you come up with a language model, it will only take care of relationship between immediately previous word and the next word. But this is a transformer. As I said, it has taken into consideration the self attention mechanism, right? And many other things, right? There are like lot of things, powerful things happening. So it is able to relate the next word not only to immediate previous word, but all the words before it, right? Connections. And that's why it comes with a even better realistic kind of word. Okay. So that's the whole idea. GPT-2, when trained, came up with this very good model. On the right hand side, okay, the bold text which you see, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. Now that is definitely a joke, right? But it's given as a starting prompt to this GP2 model, and this is what it is, right? So if you read that, can just take a couple of minutes to read that. It will sound very real. There is nothing like nothing you cannot make. Can you make it out that it's been written by a model, an AI model, and not a human being? Hey, can you do let me know how you find it? This was all completed by the GPT-2 model, and we still have a better model, which we'll cover in the next slide. Isn't this really realistic? I'm assuming you're still reading this, right?
It's a fictional story, sir.
Yeah, it's a
I think
fictional, but imagine it's written by a machine.
The
So
the
isn't
sentence
this like,
formation, the
yeah,
meanings and all. Yeah,
And even the emotions, right? The sentiments, I can feel that it is trying to communicate that humans and unicorns were living in harmony before.
Yes. So it has picked up that quality, right? So it has in the some articles, a lot of articles would talk about how two different kind of people live together, right? Maybe two different people of maybe different languages, different countries, they have lived together in some reason. It has picked that theme up and fitted it here, right? Fit it here. So
Oh, okay.
that's
You mean to say that like 8,000 million pages, right? Whatever the input we are given, so it has taken this as input and joined, like extracted information from all those million sites and then stitched up a story, right? Something like that.
yeah. So that knowledge which has gained is helping it to make these realistic stories, right? So
Yeah.
as you said, even if somebody will read it, it will they see. You remember RNN and LSTM, the output was not that great, correct? You could make out after some time that it is actually generated by machine because it did not make any sense in English, right? Especially with RNN. The first one which we did in RNN, it takes a lot of epochs to train it to like generate decent English, correct? If you remember, LSTM we generated the Alice in Wonderland story text, correct?
No, but here, like in this case, like he has get that scientist perhaps in Columbia University, something right, La Paz and all. How did like is it like is it
so
equating to Anders or something?
yeah. So no. So this is something which it generated randomly. It is using its training to generate the next word, which makes sense, right? It is not so okay. Just to clarify, nothing is real here. Everything is fake, right? But it is very realistic fake. Okay. So because it has been trained on so much data, it is very good at writing sentences which make sense, okay, or which make grammatical sense. Maybe they do not make logical sense, right? Because unicorns don't live, right? They are not real. But it will be very good in writing very creative stories, right? Creativity is very good for this model. It
Yeah,
is very
the way the model is written, we can kind of
yeah.
give 1% chance that they exist.
Exactly. So you will start believing probably there is this guy, Jorge Perez, evolutionary biologist. There is such a guy, right? So that's the problem. That's so the problem with this model is one of the biggest is OpenAI company, you might have heard of it, is the creator of this. Now GPT-3, I think GPT-3, I'm sure, is now under Microsoft. OpenAI has shared the API with Microsoft, rather shared the whole code base, and Microsoft has given the API to you can purchase API from Microsoft for that, right? So yeah, so the problem with this is when OpenAI came up with this, right? The blog article, if you click on it, it will talk about how dangerous this is for fake news, right? If you give it some starting article, right? Okay, Trump said this and that, it will complete it, right? So
Now in
that's
this
the
Ukraine war, it will be a blunder actually.
yeah. So again, this is very powerful, but the problem is it is not a human, right? So it will start saying things which do not make sense, even though they are English grammatically they are correct, right? So so if you see, okay, evolutionary several companions when they found a small valley, blah blah blah. Okay, it is making perfect sense, but ultimately it is not real. So again, it will be not that great. Yeah. So I mean, it's not realistic, but it's not logically correct, but it will make sense. It will be very realistic. That's the problem with GPT-2. So you can ask me what is the business use case. I will talk about it. But one interesting thing, GPT-2 can be fine tuned. You know what is fine tuned? We did it in machine vision. We trained on okay, and we will also in BERT model in transformer also. I talked about fine tuning. We'll try that today. Fine tuning again. Not again, we'll try that for the first time, fine tuning, right? Towards the end of the class. So fine tuning is basically you can train on a particular data set to generate something related to the data set, right? The labels or something. Now GPT-2, so for example, okay, I think, okay, can you give me some industry domain you work on, one of you?
Healthcare.
Healthcare. So healthcare data, if you take maybe maybe it's discharge summary report of hospitals, right? And you train a GP to fine tune on it. Then if you give it a sentence, it will start giving you sentences which are themed around that. It will start saying, okay, you give it a sentence like, okay, what is the weather today? Then it will start completing it saying the weather looks good, but you should keep taking maybe 2 paracetamols if the fever comes, right? So that's the funny thing. It can pick up themes if you fine tune it on a particular kind of data set from that, and it will then complete sentences on that theme. Okay, did you get that?
Ravi,
Yeah, Shish.
so in healthcare, they generally write a report for ultrasound or MRI, tests they do. There'll be a written report of around half a page or one full page.
Mm-hmm.
So, do you think it will be possible to train the model looking at the MRI scan and creating that written report?
Yeah, that's they OpenAI has done that. It's called a unified. They have done something which is related to both text and image. You can
Okay.
refer that. It is something new, and there is just like last month, Facebook did a unified language model for both text and image, right? So
Okay.
that's something you can also look at. But the best bet is a zero shot model, which came last year, which was again OpenAI, where if you give them an image, if you give it an image and you write labels for it, right, it will give you which is the closest label to that image, which is very powerful. So to your MRI thing, that it can it can find out which text portion is closest to that, and then it can probably start generating that. Okay, so that similar work has been done. You will have to look up OpenAI's blog from last year. A lot of blogs and several blogs which are there.
Okay. Thank you.
Okay, so let me quickly give you a demo of Hugging Face GPT-2. Hugging Face is basically the company which came up with Transformers module. Okay, I'm sure you're not seeing the. Let me unshare this. Okay, can you see the page? This page. This was a link on the slide. Okay.
We can still see the PPT.
Okay, so let me. Okay, let
No,
me.
we
No, no,
could
we
see
could
the
see.
page.
We could see the page.
Okay. Now you
Yes,
can
Not
see
it,
that, right?
yeah,
Yeah. Okay.
I.
yeah,
Yeah. Now
Hugging
I can
Face.
see.
Okay. So if you see GPT-2 again, the first version, the GPT-3 was not. So GPT-2 is a transformer, very large corpus, blah blah blah, right? So you can actually do again transformer pipeline. I hope all of you remember, right? We were doing some few number of things using that. So you can do this text generation pipeline task using GPT-2, and it will generate it. Generate 30, 50, 60, however you want. Let's do this. I like learning class. Okay, let's compute using GPT-2. Learning algorithms through a deep learning app like that is important. It is one example of a deep learning game have been trying when I'm working with Google Analytics I. So see, it is trying to complete that. So let's do this. Convolutional neural network is my favorite computer vision model. Okay, extremely techie sentence. Let's compute. It's completing. See how nicely it is completed. Convolutional neural network is my favorite computer vision model since it only takes around 8 milliseconds for convolutions to occur. This information is probably most likely wrong. It has picked up the theme from somewhere. It has just fitted a number to it. I think there is one limitation where convolutional neural network is a little bit harder to solve with the following key performance, right? So don't treat whatever it completes as a truth, but yeah, it's creative writing at its best, right? Hope you understand this. So let's do this.
So
Can
where do we use this? Like where you can.
so yeah, so people are using this for, as I said, creative aspects, right? So you can use for advertisements, writing, creating text for advertisements, creating text for marketing campaigns and other things. So GPT-3, they are built apps. People are building apps using the API for generating creative text for marketing campaigns and other things. Wherever creativity is needed, this can be used. Okay, can somebody give me a text here before we take a tea break? Small break. We'll come back and do GPT-3. Can somebody give me a text here? Any text?
India versus Sri Lanka test match.
I mean, you can give it a text. You need not give it a phrase. But India versus Sri Lanka cricket test match is this week. Okay, is this okay? I don't know why it is Priyanka. It is giving why. Okay, probably.
Sri Space Lanka.
Okay, we'll do that.
FYI, I'm Sri Lankan.
Yeah, I could make it from your second name.
Okay.
Yeah. So, do you speak what's the language? Sinhala?
Sinhala,
Sinhalese?
yes. My
Sinhalese?
mother tongue is Sinhala. Yeah.
Okay. Cool. Add to dictionary. Okay. Sorry, guys. I think. Okay, it's fine. Yeah. Okay. Oh my God. it picked up some wrong history, fake history. In the fourth test at Bhopal, Bangladesh have faced Delhi in 7 in 4 innings. How can Bangladesh face Delhi? See, this is the challenge. If you solve this challenge, it will be a good solution, right? This is really fake. Anybody who in Indian or for anybody in the Asian subcontinent, Indian subcontinent, will immediately know that why would Bangladesh face a Delhi normally, right? This is a city and this is a country, right? So
And
Pakistan
Pakistan.
is in 6. So that's it. So it's pure nonsense, but yeah, it makes English in English it makes sense. But yeah, that's for GPT-3 is much more improved. We'll see that after we come back after a break. Okay. Any questions before we take that break?
But still go back to that question, right? Like you said creative campaign and all. With this data, how we can campaign it? So all lies, right? In the sense, in this context,
Okay, I will show you some applications there with GPT-3, right? People have realized this can be used commercially. So the GPT-3 API is paid API.
Oh.
So it is now you can people have. So let me show you some examples. I'll keep them ready when we come back and meet next. Let's meet in around 15 minutes. Okay.
Sure.
Thank you. Thank you.
Thanks.
Hi everyone.
Yeah, hi Ravi.
Hi. I have shared a link where the applications of GPT-3 are given. We'll cover GPT-3 and yeah, we can discuss these. Is anybody else who is back? Yeah, Sharon is back. I just saw the hand raised. Yeah, I mean, people can come on camera as well. Thank you.
Ravi, that the training of YOLO
Hmm.
5 model is done.
Mm-hmm.
Have to test it now.
Oh, YOLO 5, okay. Test it. I think the code for testing is given in the same thing. You can
Yes, yeah.
do show us the output once your testing is done. Yeah. Shrikant, I think I've given one link in the chat on GPT-3 applications, apps which people are building using GPT-3. You can have a look. We'll discuss this also. It also. I think you were asking the question on
Yeah,
GPT. Yeah.
I'll take a look.
Yeah, I will just give me 1 second. I'll quickly check. Ravi is there. Anand, you're there? I think Anand was there before the tea. I think he's
Yes, Ravi, I'm here.
okay. Hey, Anand. Jyoti is there. Tyagarajan is there. Aruna is. She came for the test actually. She's there. Sharon, is Aruna there?
She was there.
Okay, before the tea break, she was there. The 3:30 break.
Yeah.
Okay, then she'll join. Okay, no worries. So Ashish is there. Hitesh, I saw. Hitesh was there. Kiran is there.
Yeah, I'm here.
Krishnakant is not there today, I think. Madhukeshwar is there. Muzammil is there. Pradeep, I think, is not there today. Sharon is there. Shrikant is there. Shurendra is there. Taruka is there. Tushar, I think both the Tushars are not there. Deepak is there. Amit is there. Okay. Yeah, folks who have come back, please cameras on so that we can start. We'll be starting now. I hope somebody. Okay, I'm starting. Yeah, so GPT-2, I just gave you a quick demo. So GPT-3 came a year after GPT-2, almost a year after GPT-2. It was around and again in 2020, right? So Again, it will be, it's as the name suggests, it's a next version of GPT-2 like kind of models, but it's like pretty impressive. Some of the numbers here, training data, right? So I mean, if you remember, first class, I covered the token concept, right? So when you train something, each character is called a token in NLP, right? So imagine the number of tokens which GPT-3 is trained on, these many data sets. Common crawl is a data set where like 60% of training data set is of common crawl. Web text is around 22%. Books one, books two, and Wikipedia. Wikipedia is 3%. Even though Wikipedia is a huge data set, 3 billion, right? But there are even bigger data sets on which it has been trained. So naturally, the such a huge model, such a huge training data, train on it, your number of parameters is huge. So if GPT-2 was like 1500 parameters, if compared, right, this is 175,000. So 50 times bigger. No, not 50, even more, right? That's almost 10 times is 150,000. Yeah, even bigger than that. Not 50 actually. It's
10 times would be 15,000.
15,000. So
It's
100
more than
times would be
100 times.
100
Yeah.
times, more than 100 times, 175,000. Yeah. Scale is in millions here. Yeah. By the way, all these model names which you see, all can be accessed using the pipeline, the transformers pipeline thing. D5 is used for summarization. I have used it in the past. Roberta, BERT
Roberta,
large. Yeah,
Roberta, we use actually like it comes like when we are doing in Jupyter, right? I think last time for that it
yeah.
picked up the Roberta. Yeah,
Yeah, I think for Q&A it picked up. I think.
yeah.
Yeah, ExcelNet. These are all these are all transformer based models. People have done some changes in the architecture, slight here and there, or maybe major also, and the names have changed. But all of them fundamentally are transformer models. Okay. So I hope everyone is back. Let's. Okay, sorry. So let's take an example of GPT-3. Can you see my screen?
Yes, sir.
GPT-3. Okay, 1.3 billion. Okay, there is some conflict on what that other slide showed. By the way, the slide in which there is that chart was there of the parameters that is linked to the article from which I picked it from. So when you click on that image, when you have the access to the slide, I'll share it after the class. You can go through the article, right? That's a good article on comparison. So yeah, okay. Neo is slightly different. It's a smaller version, but again, it's a GPT-3. GPT Neo actually, is it 3 or? No. Okay. This is GPT-3 for sure. Yeah, I was just confirming. Yeah, it is GPT-3. Yeah. So this is another company, L Uthers AIs. Okay. And because as I said, right, if you remember, before the break, I said GPT-3 now is owned by Microsoft, right? And if you have to create an app using GPT-3, you will have to purchase the API. You'll have to get access. They'll give some free access, but for an app commercial development, you'll have to purchase the API access, right? So they have replicated the GPT-3 architecture here. So this will be as good as GPT-3 is the assumption. So again, as you can see, it's pipeline here, transformers import pipeline, generator pipeline, text generation task, model, blah, blah, this name, right? Do sample true minimum length 50. Okay, let's see the same India versus Sri Lanka example. Okay, the test match. Okay, so this is a sentence I typed last time, right?
Yes.
Okay, let's see. Can you see the number of downloads happening for this model? In a month, around 4 lakhs.
Dhoni is already retired.
Yeah, correct. But so we are going to follow the game closely to know our top 5 performers. So this looks less fake, okay, because it's not referring to any
Yeah, correct.
test between here. So it's kind of improvement. Also stay tuned to see our. So okay, can anybody else give me any sentence, please?
We can see a product title and see whether it gives a description.
Can you share something?
Yeah, embroidered white.
Can you paste it in the chat so that I can pick it up? Hope everyone is back. Yeah, Amit is back. Yeah, switching on the camera is the fastest way to help that answering that question.
I have shared it, Ravi.
Okay, I am taking it from the chat. Embroidered cotton white blouse. Can I make a sentence out of this like this? Popular selling item. Let's try that. Popular selling item in the store. In the shopper's stop, probably. Okay. Is okay. Let's. Did I spell shopper's stop correctly?
There is no apostrophe s. Shoppers.
Okay. Okay, so if you see Taruka, white blouse, embroidered white blouse, a great design with perfect combination. This is the embroidered cotton voice block. Okay, can I increase the number of text lines here? I can actually do it in this guy. Okay, minimum. It's taking default length. If I remove this guy, okay, let's see. So this is the original text you shared, right?
Yeah.
Okay, one thing to keep in mind is that's a that's a warning actually, because if it okay, this 125 pounds. Please note you will receive an email shortly with a PDF of the order form. You're not 100% sure.
Is there a way you can give certain filters saying capture the content from India?
Yes.
Or...
Fine tuning.
Yeah.
So you can train it on this description. A lot of these descriptions, right? You can fine tune on it, and it will generate what you're looking, the theme you're looking. Okay. One thing I was saying is because this is trained on text and web text is biased, it might have abusive languages also. It might have political things also, which we avoid in work life, right? So just when you use this, be careful. Some of the output might not be like safe, right? So keep that in mind, please. So okay, so I think to get back to Shrikant's point about what are the applications we have, right, for this GPT-3. So this was picked up. Sorry.
Ravi, I think Muzamil has specified. I think like this, if it gives information, it's good. Like yes, I think tried out Revit software. I think right, it has displayed some relevant information on that. right?
Okay.
I mean, if I
Yeah.
understand this correctly.
Yes,
Okay.
yes, yes. Yeah, correct.
So what is this?
This is an application, sir, like for 3D modeling. So this uses the basic, the back, the application was developed using this.
GPT-3.
No, no, no. The software C++ and it requires this DLL to run that. So it gives basic requirements to run this application on your computer.
When you queue in this Revit software,
Yeah,
it is what
it
is
give,
the
so
output of
this was the
the
description
yeah.
given.
Oh, okay. In the same page.
Yeah, on the same page.
Okay. Great. At least so yeah. So it tells you that it is slightly biased towards technical articles, right? So it is giving good output for technical articles or so yeah, let's find that out, right? So we can so fine tuning is something. Okay, let me go back. Can you guys see this? Next generation of apps. Sorry, have you? I mean, can you see? Can you confirm?
Yeah,
Yeah,
yeah.
yeah.
Okay, yeah. So okay, this was last year, almost last year, exactly last year, in fact. So first, OpenAI more than 300 applications. So that number might have doubled by now, right? So GPT-3 across various categories, industries. Let us see some of these. So Viable helps companies better understand their customers by using GPT-3 to provide useful insights from customer feedback in easy to understand summaries, right? So it is identifying theme. Okay, so using GPT-3, right? So they will have other things as well, but GPT-3 is also part of the backend. It will identify themes, emotions, and also a summary of the feedback, right? What is frustrating our customers about the checkout experience? Viable might provide the insight customers are frustrated with the checkout flow because it takes too long to load. Okay. So again, this is proprietary software for the, I mean, they have made some changes to, we don't know how they have done it, but I'm guessing they would have used Q&A model as well to answer questions apart from GPT-3. Okay. You can visit Viable. Don't just organize your feedback, understand it, blah, blah. Okay. Book a demo. So yeah, this is one. Let's find out some. Okay, so again, this is the interactive story application, Shrikant. Fable Studio is creating a new genre of interactive stories using GPT-3 to help power their story-driven virtual beings. 2C, blah blah, involves can have people. Okay, so it is for animation. Algolia uses Answers product lightning fast semantic search for their customers. Okay, platform improvements. Okay, this they're talking about. Okay, there are some of the examples. Okay. Okay, so this is so yeah, OpenAI blog is a good one to kind of keep track of. Language models, okay, solving some former math Olympiad. Okay. Web GPI, improving the factual accuracy of language models through web browsing. Customizing GPT-3 for your application. This is an interesting article. Let's look at it. Sorry. So you can customize GPT-3 for with run command is use it immediately in an API. Okay, so this is I am pasting this. You can start using the API in case you have a in future you are planning to build an API application with GPT-3. Okay. So this is the power of that. It takes less than 100 examples to start seeing the benefits of fine tuning GPT-3. So to your point, Taruka, if you feed it only maybe 100 examples of whatever your retail descriptions, right? It will start generating those. That's the power of GPT-3. Okay, so those are some of the more interesting examples, I think. Okay. So that's pretty much about GPT-3. I mean, as I said, it's an interesting thing. You can. I have done some work on GPT-2, and also GPT-3 I have not used, but GPT-2 I had used it for some of our applications. So if you have some applications, you think GPT-2 can be used, please play around with it, right? So read more about how GPT-2 is used by GPT-3, so rather is being used by companies. GPT-2 I think is free, so you can try that as well, but it will not be as powerful as GPT-3. Any questions before we move on to other topic? Okay. Yeah, before fine tuning a BERT model, I actually wanted to show the transformers OCR example. Okay. Oh, okay, let's do the BERT one first. When we'll end it with transformers. So this is a BERT fine tuning example. Okay, so all of you remember the BERT. Okay, I don't have any. Okay, I have a code for this. I'll share a link with you guys, right? So okay, BERT is a transformers based model. Okay, and a transformer is very powerful as far as NLP is concerned. Transformer based model, right? So uh, transformers original architecture is something which people came up with in Google, right? And they really released it in 2018. Now, BERT came after that. BERT had some changes compared to Transformers architecture, but it fundamentally is a transformer-based architecture. Now, some of these changes made BERT really powerful. Okay, so what is a fine tuning, right? So fine tuning is you train BERT for a specific task. So one of the examples we'll see today is identifying if a sentence is correctly written or incorrectly written, right? So does it make grammatical sense, or is it well framed sentence, or is it not a well framed sentence, right? So do you think that will have some application? In case can you think of an application of such a model?
Proofreading.
Yeah, book reading is fine. That's so when you say book reading, you're saying okay, you're saying somebody has submitted a book for publishing and it can do proofreading for that. Is that what you're saying?
Yes, proofreading. Yes.
Yeah,
Proofreading, you said.
Audible, like it can be used in Audible or something. Like.
Yeah, I mean, Audible probably is using that, probably some advanced version of that already, probably. Yeah.
Okay. Then chatbots can use it.
Yeah, chatbots definitely can use it. Lot of examples. So this is slightly deep, right? But I parked it for the end, right? The last sections. So last sessions, right? So let's do it. So I need a volunteer who will share screen. I'll share the code for doing this. Let's understand the code. No volunteers.
Previous code, I'm still on that. So do we need to do anything about it? YOLO 5.
Which one? Which one? YOLO V5. How many epochs? So
10.
Ravi, your code YOLO V5 ran testing.
Yes, I ran. No testing. I'm getting a error. So I was checking about that.
Okay.
Attribute C3 on module models.common is not found. They're asking us to reclone, get the latest one, and all those things.
Okay. Okay.
Just now we have cloned it.
Okay.
So that's the reason I thought.
Okay,
No
that's
point to
funny.
do this.
That's funny. Is anybody else getting that? So yeah, sorry. Coming back to the original question, you're asking about YOLO V5. Should we continue it? How many epochs have you done?
10, sir. 10 epochs.
I have done 30.
10 is 30. How 10 took like 1.5 hours, right? Or 1 hour, right?
10 took about 20 minutes, sir.
20 minutes. So then it's like still keep it. I think. Yeah, keep running it. Anybody else who got the error as Ravi? Same as Ravi? I think nobody ran it, is it?
No, I ran it. Mine is still third epoch going on. So
Okay.
I'm not
This
even.
is while testing we get this error. Can't get attribute C3.
Okay. And modules common. Is there anything in Stack Overflow, Gyan, which you got?
Yeah, I'm checking there. They're saying it might some libraries or they're asking to install the requirements.txt, whatever is there again. And
So we did that actually, right?
or reclone, get the latest the Git repo. But just now we cloned.
Yeah. So what has happened,
No,
unfortunately,
you
is there
moved.
is
Have you
some
moved
changes has been done.
your train models into that
Yes,
after
yes.
git clone?
Yeah, I have moved and I'm using the latest model only, whichever I trained.
Actually, I ran it. I completed it, but it got closed. The session got closed, so everything lost.
Oh.
No problem. But yeah, Google Drive is recommended for that.
Yes. But mine went fine. Everything went fine. Even testing everything.
Okay.
So I'm sharing a link. Still looking for a what do you call it? A volunteer. Otherwise, I'll have to volunteer alphabetically. Yeah, but I don't want to volunteer folks who have like shared a lot today and earlier. Okay, Ravi is. I think Ravi is fine. Ravi, Anand. You're there?
Yeah, Ravi, my older code itself is running still.
Okay, no problem. I understand. Okay. Anybody who joined late after, like not late means, I mean, when I was last checking, anybody? Jyoti has shared a lot of times. So Tyagarajan also, I think, has shared. Aruna is back. Okay. So Tyagarajan, can you share, please? You have Google Colab, right? With GPU?
Yes, Google Colab. Yeah, I'm using.
Okay. And your speed and everything is fine, correct? Okay. So please refer this link, everyone, all the people in the class. Oh, I pasted it twice, is it? Why did it went twice? Okay. Yeah, so this is a slightly old one, but when BERT came out, they had this good example of fine tuning it. So this is a good long example, but let's do it.
Where is the data?
It is downloadable. There is a Google Colab actually link also.
Okay.
Let me. I just pasted the Google Colab link. If you can go there. Yeah, this is the article. Google Colab link is. Okay, so the data set can be down. Data set is a very small data set. It's like some few thousand text entries, nothing else. But I mean, one issue the data set might be the quality of data set, but let's see. Okay, so quick introduction. This tutorial is about BERT with PyTorch library of Hugging Face, right? To fine tune a model. Fine tune a model again. Quick description is model is pre-trained, but you are fine tuning it to do some particular task. In this case, you are fine tuning it to identify well-formed sentences. That's it, right? The beauty is it will fine tune on not like it doesn't need a lot of data for doing that, and the accuracy will be pretty good, right? That's what the outcome here is learning. And this is just one example. Transformer models can be fine tuned to do a lot of things. I will share a book link with you. You can refer that in future. Okay.
So what is
A lot of
PyTorch
books
like?
on
PyTorch is
transformers. Yeah.
PyTorch, what is it actually?
PyTorch is a very famous library.
Okay.
So just like Keras is like most of us have used Keras from a long time, but PyTorch is slowly becoming more popular because of some of the features it has, right? So it's a very popular library. It is and again deep learning based library, right? I mean deep learning library, and it is used a lot in these applications of machine vision and NLP. Most of them use PyTorch now.
This example, we are using PyTorch, right? Instead of
Yes,
Keras.
yes. So okay. So can you scroll down, please, Tyagarajan?
Excuse me.
Yeah, I mean fine tuning and all. You can read it in your free time, all of you. So it's better results and less time and all, right? So let's run the code. So it's first testing if you have a GPU or not, right? So most of you, I mean, folks on Collab will definitely have a GPU unless you have not selected GPU. So for you, it is run. It is saying not run all. Let's do run one by one actually. Okay, you want to do run all? It's fine. Do run all. I'm fine with it. Are you running or?
Yeah, running.
Okay. Other folks also running? Any issues? Anybody whose YOLO V5 is producing output, let me know. If you can provide some commentary also, it'll be nice. You know which one you're running. I can do that. Actually, I can help you with that. So yeah, the first one is run, right? So one GPU available. You have a Tesla K80. Okay, is everybody getting the same output, Tesla K80, or somebody is getting some other model as well?
For me, it says GPU phone, but doesn't display whether nothing is coming, like which Tesla or whatever here, right? It
Okay,
says a GPU phone.
No, but that is strange. It should have a name. Okay. Anybody else for whom something different is coming? For me, it always comes actually Tesla. Not sure what happened. Maybe they're using unbranded one or something.
Sorry. Maybe yeah, it is coming actually. Like I was checking the previous output actually. So
okay.
There it detects GPU, right? Whether it is there or not. Okay, fine.
Okay. Everybody else got the. This is very simple. Just quickly, yes, no.
Yes.
Okay,
Yes.
fine. Okay, so installing Hugging Face library we can quickly do, all of us. Transformers. Yeah. So it is done for you.
Should I? You can browse the file system of the Colab instance in the sidebar on the left. Should I do this, Ravi?
Just give me 1 second. Important call came. Just give me 1 second. Yeah. Yeah, I'm back. Sorry. So there's some issue with my car. Okay. So yeah, you need to download this file.
I just rerun this. I'm getting some answers here. Text it's number of training sentence.
Yeah. Yeah, is that the output you got? The training sentences, number of training sentences?
Yes, yes, yes.
Okay, okay. Yeah, is everybody running this or? So if you see,
Yes, Ravi, taking
okay,
time.
sorry.
It's taking time, Ravi.
Okay, taking time as in
I
downloading this data.
did run all. No, I did run all, and it got stuck. So I'm just gonna see
Acha.
that again.
Okay, so if you see the sentence source is fine. Label is 0 is the incorrect sentence. No, 0 is grammatically correct or incorrect?
I'm not sure. Grammatically.
I think 0 is the one which is okay. Let's okay. So go down the documentation will say.
Okay. 0 unacceptable grammar error. Yeah.
0 is error, right?
Yeah,
Okay, 0 is error and 1 is correct. Okay.
correct.
Okay. So yeah, so these are the 0 and the 1 is the sorry, 0 is acceptable, unacceptable, which is the error. 1 is acceptable. Okay. Now here are 5 sentences which are labeled as okay. Let's look at those sentences. John made Mary cooking Korean food. I wonder has whether Mary worked for Microsoft. Gary touched the stick into the cat. Some man has even better beaten the centaur. John is ready for you to inspect bunk. Some of this actually in everyday English we sometimes end up speaking if we take shortcuts, right? But yeah, it is grammatically incorrect. So they are just showing you it's a very difficult task. Unlike sentiment analysis, where you can train a model and get high accuracy, this is not that great easy. That's what. So okay, so they are extracting the sentences. Okay. Now, okay, this is an important section. So for BERT, you need to follow a format because when BERT was trained, they did this specific format training, right? So there is a special token called CLS, which starts any sentence, and between two sentences, there is a separator token, SCP separator. So that's how they will convert the entire data set you have to that. So, okay, BERT tokenizer you have loaded. Tokenizer, you understand the meaning of tokenizer? Can anybody tell me what is a tokenizer?
It will split
Splitting
the
word.
words sentence
Sorry.
into tokens. Sorry.
That's correct. Tokens. So BERT tokenizer specifically, why we are talking about BERT tokenizer? Because BERT pre-trained model has its own tokenizer, which when it was training on that specific data set, it got a tokenizer created, right? So why is the tokenizer needed? Because we never train on words. We train on their numbered representations, correct? So when tokenizer was training, when BERT initially, they had created this mapping. Okay, the word him has the word token ID of 5. The word Bangalore has ID of 6, right? So that ID to the word mapping is why the BERT tokenizer is needed, because using that you can convert words to numbers and numbers to words. Okay. Hope you understand why tokenizer is needed here, specifically BERT tokenizer. because we are training a BERT model, fine tuning a BERT model. Okay. Now, if you, okay, the next one is, okay, so that's the one. Token IDs you see 2256, 2218, blah, blah, 2814, 2180. So that's the number for each word. Okay. So there are some simple functions in every, like BERT has or transformers have, which can encode and decode. That's what you're saying. Now the next one is the one where you do a required formatting. Okay, so we are read those lines. We are required to go above, please. Go scroll up.
Special tokens.
Yeah. So at the end of every sentence, the way BERT was trained is we need to append the special separator token. Okay. This and so that's something which tells the model that the sentence has ended. So SCP token needs to be added, and I mean ignore all the other history. They're just saying why it is so in the BERT training. CLS is basically it's a classification task, right? So the BERT model should know what task it is being used for. So you add the word CLS token to the beginning of every sentence. So that's it. That's the two things you need to do to your data set, the data set which you are training on. So go down.
Shall I go down after this?
Yeah, go down. Yeah, I mean, all these attention mask and other things are not required in detail. Yeah.
Okay.
They're just explaining to you the original transformer layer and how you are making it similar to that, right? That's what our original BERT training for. Yeah, okay. So this one is for every sentence, you are just taking every sentence, okay? And then breaking it up into token, encoding it, and then adding the special tokens as well. So that's what you're doing, add CLS and separated tokens. And max length is your whatever your maximum input ID's length is. You can print maximum length actually. I think it's 47 here, what it is printing. Is this clear?
So max length is the length of the sentence, right?
So if you remember in the NLP initially in IMDb, we were doing a max max length of for padding, right? We were doing, okay, if it is less than max length, we were adding 0.
Yeah.
So what they have done is they've taken in all the sentences, what is the maximum length of all the sentences? That's what they want to keep track of.
Right. Okay.
So it is they're just finding out, okay, which is if they have initialized max length is 0, but any input ID for which the max length is more than 0, right? It's a maximum rather. Comparing it with all of them, they're saying, okay, if max length is more than the last value, then update max length. It's a simple maximum number logic that they put. Okay, so go down. Now we are ready to perform the real tokenization. Okay. Tokenize all the sentences. Okay. Okay, so they are tokenizing everything now, including the special tokens into those IDs, right? And then they are making into tensors. Now, this is something which is specific to this kind of model, a PY-torch model. It runs on tensors, right? Tensors are again containers of numbers. Okay.
I think this is throwing error, I think.
But what error is throwing?
Tyagarajan, can you scroll down?
I think for him it worked. For him it worked, is it?
Which step, Ravi?
No. I think Shrikant is saying it's throwing an error for him.
Okay. Yeah, this one is
It works.
Tokenized small percentage.
No, but for him, it is a warning, not an error.
No, for me, it is a torch not defined.
Torch not defined, then you're, I think you have missed
No,
one.
no, you didn't import a torch.
Yeah, torch. You missed the import torch line.
Check the second cell.
Yeah.
Oh, okay.
There are two cells similar to like GPU. Check it.
Yeah, and it's a very small cell, so you might have missed it. A lot of text surrounding it.
Oh, okay.
Okay, so this is a future warning. Let's ignore that for now. It's basically something which is going to go away in future. Okay, so training and validations. So now you have taken all those things, the input IDs and the labels. As labels is nothing but the 0 and 1, which we discussed as sensors. Now you will train your model on that. Okay. Divide up our training set to use 90% for training and 10% for validation. Okay, so this is
What did we do in the previous block? It was a big block of code.
yeah. Go up, please. I mean, scroll up, please. Okay, Tyagarajan, I think you have, let's find another volunteer. So let's anybody else who wants to share?
Yeah, I can.
Okay, you want to share? Okay.
Anybody? YOLO V5 done?
Sir, it gave the same error for me as well. That attribute error C3.
Okay. So on the slide I'll be sharing, there is another example for the this. Just try that out. I'm surprised that is not working. Yeah, it should work definitely. Okay, input, or maybe see the other thing is sometimes sometimes the whole repository breaks for a few hours, because people might have checked in some code which was buggy. Might have happened that way as well, right? Maybe they'll find and roll it back. Sometimes code starts breaking in such open source libraries, but it is rare. That is one possibility. Okay. So, okay, to your question, input IDs and attention masks are two inputs which or two things which are required to train a BERT model. Okay. So masks. So if you remember, I was talking about how a transformer. So okay, how a BERT model is trained is it's a mask language model. So you will take a sentence, mask some portion of it, hide it, and ask the model to predict them using the unmasked thing, right? So attention masks will have those uh, numbers which will indicate which are to be masked and which are not to be masked, right? And input IDs are basically the text IDs. Okay. So if you have the number, okay, hi, my name is XYZ, then hi, my name is all will have those things. Okay. I mean all the numbers for that.
Okay.
Yeah. So for every sentence now, encode plus will tokenize the sentence, add CLS at the beginning, SEP at the end, map token to their IDs, pad or truncate the sentence to max length. Okay, thank you. Create attention masks for pad tokens, right? This is very BERT specific sentence. Create attention masks for pad tokens. So basically, it's saying some of those inputs will be randomly assigned to be masked. That's what it means at a high level. Okay. So that's what this whole thing does. Encoded dict is tokenizer.encode plus sentence add special tokens to max length 64, pad to max length true, return attention mask true, return tensors pt, return pytorch tensors. Now add the added encoded sentences to the list. So it is everything is in a loop, as you saw, right? So it is happening for each sentence in the whole sentence list. Okay. So it is being added to this input IDs appended. The input IDs will contain this whole converted thing, which is suitable for BERT training. Okay. That is what is happening.
Yep.
Attention. So attention mask will have the attention related stuff being added. Now, so this is a list, and when you are using the PyTorch model, FYI, you need to convert everything into a tensor. So that is a one-line command in in PyTorch. So in Python, input ID is torch.cat, input ID is dim0. Attention max also becomes a tensor. Okay, labels becomes a tensor as well. Torch.tensor labels. So don't put a text code here, but there are simple test codes you can find on web. You can just print out. Okay, convert a list into a tensor, right? And you can print both of them and see. So it will treat it as a tensor because it is able to run the deep learning code use on GPU much more efficiently when something is in a tensor format. That's why it is converting everything into a tensor. Okay.
Okay.
Print sentence zero now is a list of IDs. So it is just doing a test here. Original was this: our friends won't buy this analysis, let alone the next one be proposed. By the way, this looks like to me a very good sentence. I don't see any error. Do you guys agree?
Yes, sir.
Yes.
Okay. So by the way, you saw the 47 length. Most of it is zero because it is a short sentence, right? So all the IDs are here. Okay.
Yeah.
Okay. Cool. So that's clear now. It's
Yes.
converting things to BERT format.
Right. Okay.
Okay. Now training and BERT is already trained. We are now fine tuning it on this particular data set. Just give me 1 second, please.
Right.
Hello. Hmm?
Yeah, I'm back. Please give me one minute. Please continue running this code. I have to make a call. Actually, there's some issue with my vehicle, and I have to call the service station to get it fixed. Yeah, just give me 1 minute.
Sure.
I'll
Yeah.
be- yeah. Yeah, I'm back.
Yeah, Ravi, let me share again.
Mm-hmm.
Right. So we were into this one, training and validation split.
Okay, so yeah, so now it's okay. So this is again a TensorFlow feature where you can combine a data set, input ID, attention mask, and labels into a tensor data set. Then you can specify the 90-10 split using that particular syntax. Train size is 0.9 into length data set, right? Now you can split them randomly, and then so it is 7,700 is the training sample size, 856 is validation sample. Go down. Now they're creating something called as an iterator. So Torch gives you this facility to not need to, you don't need to load the whole data into the memory. It will just load the data which is essential for training. That saves you memory, right? So batch size for training, based on that, it will keep loading 32 size of data every time. So that when you give and this you specify the train data loader and validation data loader, it will keep on loading 32 batch size. Okay, so they recommend 16 or 32, by the way, for doing this, right? So okay, till now, what are you seeing? You're seeing BERT can be fine-tuned to do some specific task, right? This is what is happening here.
So over here we are just loading the data, right? I mean, our training is not
Training
yet.
will happen. No, you're preparing for training to happen. So you have loaded the data, your
Yeah.
specific data, and you have a BERT pre-trained model. Now you're fine-tuning it. So let's see how you do.
Yeah.
Next step is train your classification model.
So we are using BERT for sequence classification.
Yeah.
This is the
Okay,
one.
so it is having these many classes provided for fine tuning. We will be using sequence classification. So that's what it is doing. From transformers, it is importing this particular method or class rather, but for sequence classification. And it is doing this Adam W. Adam W, I think, is a loss specific to transformer optimizer function. And BERT config is the BERT configuration of the BERT architecture.
Okay. Ravi, you have put yourself on mute. We are not able to hear you.
Sorry. So this, okay, so this, go back to the code. Yeah, so this is specifying that BERT for sequence classification from pre-trained. Okay, and BERT base uncased is the model, one of the pre-trained models. It says name of that model. Number of labels 2. Okay, in case you are doing some other task with 3 labels, you could have put whatever number of labels. Output retention false is whether the model returns attention weights, whether the model returns all. Again, this is very specific to BERT architecture. You can assume, okay, for this particular, I mean, this kind of task, you will keep it false, right? Now you are writing this, telling the PyTorch to run this model in GPU. Go down.
So this is the one model.qd CUDA.
Yes, CUDA. So why is it showing?
Sorry,
1 second. Why is it showing the output as? Okay, this is the architecture of the model it is showing. Yeah.
Yeah. I
Okay.
think this is where get all the model's parameters as a list of tuples.
Okay, it is just showing you what are some of the parameters, right? So First of the 12, the output layer. Okay, so it is showing you the parameters name here. What is so param 0 to 5. So these are all some of the functions listed attached with each BERT model or BERT kind of model, right? So named parameters, if you call and make it a list, you will have BERT model has 201 different named parameters, and those are the params. The first 5 is this much. Okay.
Yeah.
Again, these all things are very specific to transformer architecture. So don't we'll not go into too much details, but this is just showing you what are the different layers, right, of the the BERT architecture. Okay. So that's where they are now using the last one. They are using this optimizer and learning rate scheduler. Basically choosing which optimizer to do and learning rate. Okay.
Yeah. So Adam W is the optimizer as we discussed.
Yeah.
The learning rate.
Yeah. So by the way, Adam W is a class from the Hugging Face library, and that's weight decay fix. So it's not an optimizer. To be more accurate, it's a class which takes care of training. So it is giving some parameters where learning rate and is kind of specified. Okay. So again, why we are doing all this? Because this is specifically demanded by the BERT, the way BERT has been designed or trained. Okay.
This is get linear schedule with warm up.
Yeah, this is if you read the documentation now between 2 and 4. So that's the beauty of when you do fine tuning with a model like BERT, you do not need to run it for 30, 50, 100 epochs. 2 to 4 epochs is fine. Okay. It will run it. It will learn it. Overfit. So epochs just 4 it has given, but they're still worried that it might overfit the data. So 2 to 4 is what is needed. That's the beauty of running a fine tuning code with such a powerful model.
Okay.
So total steps is length of train of data loader into epochs, right? So that is 16 batches, or sorry, batch size. Okay. So can you go to the training loop piece?
Yeah.
So yeah, the function to calculate the accuracy of our predictions versus labels. Def flat accuracy preds and labels, pred flat, np.argmax flatten 0, labels flat, labels dot flatten. Okay, so this is basically the accuracy comparing your 1 and 0 output to the actual 1 and 0 output. And helper function for formatting. Okay, so it will show the elapsed time. Okay, go down while training the model. Now they are ready to start the model training.
Right. I mean, there is too much of code over here, and then.
Yeah. So basically that's the standard BERT training code. Okay. So it's I mean all you need to keep in mind is the earlier changes which you have done where you have specified 2 classes, right? That's something which you need to do. Otherwise, this will hold good for any other fine tuning you do using BERT.
Okay. It ran for like 4 epochs, and this is the.
Yeah, that's the time.
Accuracy is 84%.
Okay, so 84% is pretty decent. It was a hard task, and the number of epochs took like maybe a few seconds for you, right? What is it?
No, not
25
few
seconds?
seconds. It was in minutes.
Okay, fine, minutes. So 2 minutes 33 seconds. Okay, but you are able to train a model with 84% accuracy without I mean with just maybe 4 epochs, right? So that's the effect of BERT, or that's the power of BERT.
So it says the total training time took 10 minutes.
10 minutes 35. Okay.
Yeah.
Fine. Anybody else who has run this? Any total time taken?
Yes, sir.
What's it?
Yes, I got exactly 10 minutes.
Okay. What was your accuracy?
It took around 8 minutes or 5 minutes for me, and accuracy was 83.
Okay, cool.
Okay.
Okay.
So we have the
Yeah,
explanation of all
yeah,
the.
you can see that. Yeah, that's pretty much. You can. There is a testing code as well. You can run that now or later.
This one, right?
Yeah, yeah. So okay, so I was talking about a book which gives all this fine tuning, right? So as you can see, each fine tuning is actually very specific to the architecture of the model you are fine tuning. Correct? You saw there's very specific syntax and other things which it requires. Correct? So this all requires you access to documentation, right? So for that, I'm sharing a book here. The book is called Transformers. Again, not everything in that book is required, but people who are interested further in fine tuning for various tasks, they can do it. I need to search for. Ah. Yeah, so I've just pasted that book link. You can download. Yeah, that's pretty much it for the fine tuning. I just had one topic on transformers for machine vision. I'll just quickly share and then we'll open it up for business use case discussion. Any open questions you have, any discussions you guys want to do? Yeah, we'll spend around 20 minutes in that. Is that okay? Okay.
Yeah.
Okay, sure. So let me share screen. Okay, I'm giving this collab book. We will not go through line by line, but I just want to show you the very interesting topic. This topic is just picking up. It's becoming slowly widely discussed, and also probably by next year this time it will be like a strong contender for many of the existing machine vision techniques, right? It might replace them. Just sharing the with you guys. So transformers, we all know, we just discussed, right? So transformers, apart from text, they are also being used on images. Okay, so what's an interesting thing or interesting way the transformer is being used on image? Let's can you see the slide?
No, it's empty. This, you mean the PPT?
Yeah, empty PPT.
Yeah.
I'm drawing something. So if this is an image, okay, and maybe this is a building we have in this, maybe something like this, okay. Now transformer, the way it learns on text models is it will break it up into chunks, okay, and it will calculate attention between them or relationship between them, as I have told earlier, correct? Self attention, right? Now, so when that was text, now in the image, what it does is, because it is breaking them into like whatever 16 into 16 pixel chunks or 32 to 32 pixel chunks, it will now start making connections between this chunk and this chunk and all the chunks, right? So it learns strong connections between the images, okay, and that's how, and then you are training it with a lot of other images as well, right? So that's why it is very good at making connections and understanding the images much more deeper than probably just a CNN. Okay, so that's something which you need to keep in mind. A transformer is breaking into chunks these image portions, then finding relationship between them. Okay, that's how it is learning. And this is and now people are showing that it is giving much more better results or stronger results in case of things like OCR, optical character recognition. Let's see how an OCR with transformer works. Any questions? Okay, so I'm not running this collab. You can run it. It's pretty self-explanatory, right? So you have to install transformers first. Okay. Then in that you will, this is the image. So this is a handwritten image, by the way, right? Handwriting. Okay. And you can do this OCR, optical character recognition, or OCR on normal text, like maybe printed output is not that easy, but it is absolutely difficult on handwritten text, as you would know, right? It is difficult to, like, I mean, handwriting differs in so many ways, right? With between people to people, right? Varies from people to people. So here you are importing module called TR-OCR processor and vision encoder decoder model. These are two specific libraries within transformers which are taking care of this, right? And this is what it read. It was able to read just a 3-line code, few imports. Industry, Mr. Brown commented, "Isoli, let us have a." Okay, so it got almost everything correct. Did you see that? This is the output.
I think doctor's prescription, this will be useful, I think, sometime.
Yes, definitely. I have tried it for reading data from this measuring tools like multimeter, which people use for electronics, right? So multimeter screen, normal OCR doesn't capture it, but this guy was capturing it. This particular module. Again, hope you have done it. Again, is where is the output? I hope you have done it. Okay. So it is very good at printing OCR from or like converting handwritten text to digital text or output, right? The other thing which it is good at is reading text from specific portions of these invoices or bills, right? Like a scanned receipt. Now, why is it noisy? Because the ink quality and other things are sometimes not that great, right? So they have cropped it at the top and just captured the name of the store or whatever location, and it got it almost correct. I think it's correct, 100% correct, right? So this is an interesting area. I leave you. I mean, this is probably the last item of the classes as far as topics are concerned. This is very hot area now. Just 1 year back, it was introduced as transformers. How can they be used in machine vision? And this is one of the established use cases which people are using a lot. So I want to share this with you. Do keep track of this. Okay. So that's pretty much it for like the session. So uh, any questions? And also apart from that, let's have some maybe few 5-10 minutes discussion on specific use cases you might have from your industry or your domain, and you want my inputs on.
So Ravi, sorry, please go ahead.
Yeah, I mean, yeah, one of you can speak actually.
Yeah, I will speak now. Okay.
Yeah.
So Ravi, what I was asking, not from the domain, I do not have
Yeah.
any use case as such, but I was just
Yeah.
thinking from the project perspective.
Yeah.
Can we? I mean, will there be any idea that you can share for the project? Like, I would be interested to take it up.
No, so I see a lot of interesting projects are combining various kinds of data sets for in the model, right? So, for example, Can you do something which combines both text and image now that you have studied machine vision, computer vision using deep learning as well as NLP? So can you do something which is like using both the concepts and do some project, right? So maybe, so I think there are use cases where both image and text are required, right? You can think of some of these use cases.
Okay. Let me give a thought over it, and then probably I'll come back to you for any inputs if I need. And also,
Sure,
yeah, I will connect with you for a few of the issues which I have with my code.
sure.
Thank you.
It's not about the use case. You used used in that codes, right? Like callbacks, concept
Yeah,
of call.
yeah.
Just lost it actually. What does it mean? Could you just repeat? Like we
Okay,
used like the
good question.
fine tuning. What are the
So
callbacks?
callbacks is basically saving you time. So it is saying, okay, based on certain conditions,
Mm-hmm.
if so, you must have seen one of the examples which some of the examples in which we ran, the improvement was not that much, even if you run for 30 epochs, right?
Mm-hmm.
So callback, what it does is it will compare the validation loss from last epoch to current epoch which is running, and if for 2 or 3 epochs the validation is less than like a certain threshold,
Oh,
it
okay.
will stop the code, right? So
It will
that's something.
save that particular epoch, the
Yeah.
best.
Best
But
epoch, it
in
will
our case, it was not stopping, right? I mean, it was we used callback. Still, it was executing
no,
all
but
the epochs.
so that means that in your case the model was running properly and learning. I mean, the validation accuracy was differing, or loss was differing by a great amount between each epoch. So it will save you time, and it will save the model for you, because I mean, so that you don't waste time in running something for 100 epochs when after 5 epochs it is not learning anything.
Oh, okay.
Right. Okay.
Anything else?
Yes, sir. Can I share my screen, sir?
Yeah.
Uh, so this
Yeah, now,
is
now it's almost the end of the class. I would hope people will come on camera now at least.
okay. I'll turn on my camera.
Yeah.
Let me just. So this is one of the scenarios. Like, see this error, what you're seeing here. It is in some other language, not in English.
Yeah.
But this is an image. So like when you're troubleshooting these kind of errors, it is very difficult to key in Google Translate and then convert it. So is there
Correct.
any way wherein we can just read it on the image, because you'll get an image, you'll not get a script of this.
Yeah. So I just showed you that OCR thing. I just
Huh,
pasted the
huh.
link.
Yes,
Use that.
OCR.
Use that to do an OCR.
Mhm.
Then use a transformers text that pipeline module to convert this to English. Okay.
Okay. Okay.
And so pipeline there was a
Yes.
translation module as well. Otherwise, in Hugging Face there is a translation module. You can find it out. Let me know if you don't find it. There is transformers. That's the translation libraries. It's called what is that place? Helsinki.
Helsinki.
Helsinki is that Finland's capital, right?
Capital,
So
yeah. Finland's
yeah,
capital.
so Helsinki, the name of Helsinki, they have this library in Hugging Face, which has language translation between all major languages of the world.
Helsinki.
Yeah. Okay. So I use the OCR thing which I just showed you. It is the best as of now.
OCR, like using transform.
Yeah, using transformer, the one collab
Yeah,
notebook
yeah.
I shared.
But then for that, it has to actually, read the exact portion of the image, right, where this image is there.
So the third one which I showed you had this extracting specific
Yes,
portions
the
of the
bill.
right. So use that.
Bill.
Use that. Yeah.
Yes,
Yeah.
sir.
Yeah. I mean, you have that powerful tool. Now you have to adapt it to your use case. That you can do. Yeah. The other folks, I'll quickly take a yeah. So Ravi, any questions?
No questions as such.
Thank you. ಇದೊಂದು ದಾಂಟ್ಲ ಮಿಕ್ಸ್
Hello.
Yeah.
Okay.
Go ahead.
Srikanth was speaking.
Yeah.
Sorry.
No
It's
problem. No
okay.
problems. Yeah.
Yeah, I have no questions as such. I was thinking of one of the use case. Maybe I'll connect with you offline later.
Sure. Okay. Sure. So Anand.
Yeah, Ravi, I need to run some of the code that we did today.
Sure. Yeah, but today's session is really important. Yeah, I mean, all of
Yeah.
them were, but today's was, as I said, they are most of them are really latest ones. So we should become definitely familiar with them. They are really powerful. Some of the earlier sessions were basics, but these were the advanced ones. So do practice them. Okay, so Tyagarajan.
Yeah.
Sorry, Jyoti. So that's your name is there in the list. Yeah, Jyoti.
No questions as such. For the code issues, I'll connect back with you.
Okay. Tyagarajan.
No doubts, sir. Yeah.
Okay, and okay, fine. Thank you. So Aruna.
Hey Ravi, yeah, I think I need to practice what we did today. I had
Okay.
some issues, network issues, and I couldn't, connect
Okay.
for a longer period.
Okay.
Yeah, but otherwise, yeah, it's good. I'm also doing a project on face recognition actually. So I think I will definitely connect with you on that. I
Okay.
will need your inputs, and I'll probably be using deep learning techniques there.
Okay. Sure.
Yeah, thank you.
Okay, thank you. So Ashish, you will connect anyway. Ashish, you there?
Yes, sir. Yes, sir. When will be the best time to connect to you, sir?
Yeah, let's discuss and we can connect.